This is Todd Gentile from Syncor Systems. We're going to do a quick demo here on actually writing some tests with the project. So this was from the setting the unit testing template up. We gave it a new name and imported it. Then now I want to test this screen library here, GGT touchscreen library, and it actually uses the Syncor library. So actually I'll probably just write a test on something in the Syncor library because it requires the most work. So let's first thing we need is to add our libraries, and I've already done this, but I'm just going to show you what I did. I just came into here in the libraries, and so there's the touchscreen lib and the Syncor library. I just hit plus, said workspace, navigated to wherever the library was built, and then clicked OK. And I did that a second time for the GGT touchscreen library. And then the same thing is true of the C++ include directories. I just, you can see it went through the workspace and navigated to the source folder to get both include directories. So once that's done, then you just want to create a new test. You can just right click on your test folder and say new. You only need source files, you only need header files for tests. And before I do this, I'll show you, I went and created a template in Eclipse, so under C++ code templates, under files. I have a tendency to forget to include the unit testing header itself. So I just created a, under C++ source files, there's a unit test file where it automatically includes it and then puts a suite and a test. So it saves you a little bit of typing. So when I right click here and I ask for a new source file, I just make sure that I've got the right header selected, the unit test file, and we're going to test the stream bucket feature, which kind of is an interface that can fake out a serial port that I wrote. So CPP, and we'll say finish, and there we go. We have stream bucket test, stream bucket. And let's say, what are we going to call this test? We're going to knit this without a fixture. Just do things the hard way here. So the first thing we want to do is we want to have an include to where the, so I can, where the actual stream bucket is. So it's under the utilities, and then stream bucket.h. So we've got that, and then it's in a namespace. So if you're doing that, you need to, everything's under Syncor library. In my case, stream bucket. Okay, and then I don't have to explicitly qualify everything every time. So we just get a stream bucket thing here and instantiate it that way. And unlike serial ports, since these are just sort of dumb buckets, they automatically open. So we can just check that the expected value is true and is open, returns true. And so there's a good starting point for a test. Very simple, straightforward. Let's go ahead and build. Okay, we'll launch that configuration. And bring up MTTY. Let that launch. And we'll bring up our web browser. And let's go to our page, 192. And there's our stream bucket tests. And we click that, and it passed. Good. So now let's go back and do the same thing, only let's use a fixture. And although obviously this isn't much work, often you'll have classes that require more work to initialize, or you may want to have them have certain state. So that's why text fixtures are nice. So you just say test fixture, and then you give the test fixture a name. And since, let's just call this the stream bucket fixture. And we're going to give the test itself a name, and we'll just call this init with fixture. Okay. And now let's, up above, let's go ahead and let's just create a struct, and let's call it stream bucket fixture. Those two names do have to match. That basically in the test fixture that's bringing this struct into scope for us. And let's, for now, let's just give it the data member stream bucket, and let's kind of use our conventional name here. Okay. So now when I want to write a test on stream bucket, I don't need to do really anything except my check equals here. I can just say check equals, and I can use true, and then I can go right to my member, and I can say is open. Okay, and that's the end of that test. So let's build that, and we'll see if both tests pass. Okay, let's resized instead of moved. Bring this up here, and now we should get 2 tests when we run, and there we go, and they both work. And that's the basic steps involved in writing your own tests. So the first thing is remembering to include this header, remembering to include any headers for the classes that you're testing against, and any usings that might be required. Then if you want to group them in a suite, you can. Otherwise, you can just start right with test. And then if there's some setup and teardown, it's probably a good idea to set up either a class or a struct and do that there. And you can use formal constructors, and they'll pretty much get called for each test and save you some typing and some time when writing your tests. And let's do one more test, just a little more interesting test here. Not much more interesting, mind you. And so a stream bucket, you can kind of write strings to it and then get them back out, pop them back out. So let's make sure we can pop the string after we write it. And what we want to do then is use our stream bucket and say write string. And we don't have to write anything elaborate, we'll just write test. And then here we want to make sure we can get that item back out. So let's say pop off the string queue. With an extra parenthesis. And this, what we're expecting to come back is, of course, test. And then let's go ahead and build that. And run it. Okay, and let's run our stream bucket test, and there we go. Let's do one more test that be instructive and be a little more interesting. I promise. Can't get much less interesting in terms of simplicity. Let's do another test fixture, and so do our SB fixture, and the stream bucket also takes vectors of bytes. So let's verify that we can push and pop by vector. And one of the interesting things here is how do you compare check equals on a vector. Okay, so now we need a couple other things that I've already cheated a little bit here. Since a byte is not a standard type, it is in the NetBurner library, but I've got my own definition, so I included that, and then of course I included vector, and then I've just put a using standard vector and a using on the byte, so that I don't have to type all the fully qualified names. So let's create an array to begin with. We'll just say static const byte, and typically when these eventually go over to the touch screen, they're going to be these command sequences, but let's just hard code some numbers for now. I'll put a 255, an 88, and a 25. And now I want these in a vector, so let's do a const vector of bytes, and let's just call it test vector. And we're going to initialize this with, this is the vector initialization that takes an iterator at the beginning and an iterator at the end, so you can just cheat here and you can give it pointers. So you can give it CS, and then you can just give it CS plus size of CS, and then that'll just initialize that vector with the byte array. And then we're just going to call our M stream bucket, and we're going to write this test vector to the stream bucket, and then we're going to see, now you could try check equals, but it's not going to work. You're not going to get the test to compile even, because I'm not sure what it would mean to check equal. It probably would fail. You know, are you checking address, are you checking values? But check array equals is designed to check that the values of arrays are equal, and it just so happens that it works on vectors because it's a template. So you can check that the test vector equals the M stream bucket, and then there's the pop byte queue, which returns our vector of bytes, and we can check that. And I typed something wrong. Oh, yeah, check. I should have. Let's see. Anytime you do any of these, check array equals, and you can see it takes expected, actual, and then count. How many elements in the array are you gonna check? So it wants a third item here. So we'll put that in. Okay. So let's go ahead and build that. And now you start to see, if you're going to do a bunch of tests with this byte vector, you don't want to be typing this every time. So this is something else can go up in your fixture, and then you can use it multiple times. So, and then let's just go ahead and run that. Okay, looks like the application started. So let's run our stream bucket test. And it passes, and there we go.